Welcome to the polarity lesson. So the two things to note about polarity is that one, you want to see if all of your terminal atoms are the same. Oops. And then two, you want to see if you have lone pairs on the central atom. So that would mean that it's going to be polar because uneven distribution of charge. And if the terminal atoms are the same, usually it's going to be nonpolar. So, given the fact that drawing Lewis structures is the first step of identifying if any molecule is polar or not, this is very important to understand your fundamental Lewis structures. So let's draw all these structures. And so this is a way to keep on practicing Lewis structures and to also now identify ways to see if it's polar or not. So again, we've listed that terminal atoms are the same. It's usually going to be nonpolar. And then lone pairs on the central atom would be polar. So let's see. NH3, so nitrogen, hydrogen, and the total. Nitrogen has 5 valence electrons. Hydrogen has 1 valence electron, but there's 3 of them. So that's going to give you a total of 8 valence electrons. So nitrogen would be the central atom. Let me draw that a little bit better. Nitrogen is the central atom. Hydrogen, again, as we've talked about, it's only going to be 1 bond for hydrogen. Notice that there's only 6 valence electrons on nitrogen. So we need to have 1 lone pair on the central atom. So that would technically make it polar. Now let's look at carbon dioxide. So for carbon dioxide, CO, and then total. So carbon has 4 valence electrons, and we have 2 oxygens. So that's 6 times 2, so it's 12. So that's 16 valence electrons. Carbon's going to be our central atom. And then oxygen will be on both sides. So right now it looks as if carbon only has 4 valence. It needs to get to 8 for stability. So let's try and get carbon to 8. So if we add these double bonds on both sides, you get 8. And let's see, 4 times 2, 8 plus 8 is 16. So we are good to go. And so in this case, you can tell that there aren't any lone pairs on the central atom, and the terminal atoms are all the same. So terminal atoms are really just atoms on the outskirts. So in this case, the terminal atoms are oxygen. Let's try CH4. So in this case, you can kind of just tell carbon is in the middle. And if you know this kind of shortcut of hydrogen, you can kind of just draw this without any calculation of how many valence electrons. So this one's going to be nonpolar because all of the terminal atoms, which is hydrogen, are the same, and the central atom has no lone pairs. And then lastly but not least, BF3, so boron, fluorine total. Boron has a total of 3 valence. Fluorine has 7 valence, so that's 21 valence, 24 valence electrons. And so boron is going to be our central atom. Fluorine, fluorine, fluorine. And so the special thing about boron is that it doesn't need to take a full octet. So let's see how we have 24, so 6 times 3 is 18, and then plus 6 is 24, so we are good to go. So boron is just one of those special elements that is actually electron deficient. So violates the octet rule. It's one of those exceptions. And so the answer for polarity would be A, as the terminal atoms are the same. So let's get to the second question. Which of the following is nonpolar? So you can kind of tell right off the bat, carbon and chlorine. Carbon has 4 valence electrons. Chlorine has 7 valence electrons times 4. There's 4 chlorines, so that's 28. So you have 32. 32 valence electrons. So carbon is in the middle. Chlorine, 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 chlorine. Now let's see. 6 times 4 would be 24. 2 times 4 would be 8. So you have 32. So you have an even distribution of electrons. And so you don't have any problems with polarity. So this one would be nonpolar. But let's just, for extra practice, let's go through all of these. SO2. So let's do the Lewis structure. So you always have to do the Lewis structures to identify if it's polar or not. But once you've done these for so long, you start to realize, you start to know some of these molecules from memory, which ones are actually nonpolar right off the bat. CL4 is one of the most common examples. So sulfur has 6 valence electrons. So does oxygen. So 6 times 2 is 12. And that's going to get you to 18 total. Sulfur would be the central. Oxygen, oxygen. The terminal atoms look good for nonpolar, though there's not enough valence electrons for sulfur. So let's see how we can fix this. So so of course, we have to somehow get to 4. So 4 times 2 is 8. And then 2 times 4 is also 8. So we got 16. So we just have to add in a lone pair since sulfur is in that third period. So we already have 16. We need more. So we can just add in a lone pair. And then that would be polar. So we have a lone pair on the central atom. And we've drew out the Lewis structure. So the next one is H2S. So H2S, again, as I've stated before, you don't really have to know, you don't really have to calculate the valence electrons. You can just kind of go and make sure that sulfur has 8 valence. So that's obviously going to be polar. And then lastly but not least, we have NF3. So nitrogen has 5 valence electrons and fluorine has 7 valence electrons. Multiply that value by 3, it's 21. So total is 26 valence electrons. Nitrogen is the central, fluorine, fluorine, fluorine. And so nitrogen doesn't have enough. So let's calculate it though. 3 times 6 is 18, plus 2 times 3, so that's 24. You need 26, so all you have to do is add another lone pair, and you should be good. So in this case, you have, it seems like you have a nonpolar, but you have a lone pair on the central atom, so that sort of gets the polarity because they're unequal distribution. So try this question on your own. See if you can get it. So number 1, SO4. So we have sulfur. Oh my gosh. So sulfur is 6 valence. Oxygen is 6 valence multiplied by 4. 24 total would be 30 plus 2, so that's 32. Sulfur is central, oxygen, 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 oxygen. And so 6 times 4, 24, plus 2 times 4, which is 8. So you're at 32. So that's the magical number in this case. And this would be nonpolar since all the terminal atoms are the same and there aren't any lone pairs. There aren't any lone pairs on the central atom. Whoops. My pen is acting up. The next one is SF6. So let's try and draw that one out. Sulfur is again 6 valence. Fluorine is 7 valence times 6, 42. Total is 48. So SFF. And you're like drawing this out and you're like, ooh. Hey, we already have 8 valence. Can we keep going? Yes, because of the third period. So we can keep going. Expanded octet. And so now we have 6 times 6, which would be 36. And then we have 6 times 2, which is 12. And then we have 48. So this again would be nonpolar because all the terminal atoms are the same. And there aren't any lone pairs on the central atom. So the big thing is if there are any on the central atom lone pairs. Continuing, we have BRF3. And so bromine has 7 valence electrons. Fluorine has 7 valence electrons also. That's 21 valence. You have 28 valence. So bromine would be in the middle. fluorine, fluorine, fluorine. 3 times 6 would be 18. And then 2 times 3 would be 20. No, so that's 24. So all you would have to do is add in 2 lone pairs. Oops, why is my pen so small? So it has 2 lone pairs. 1, 2. So that brings up the total to 28. So that is the polar molecule. However, I want to mention XeF4. Xe happens to be a noble gas. Xe is 8 valence. F is fluorine. 7 valence times 4 is 28. So that's 36 as a total. What's special about Xe is that if we have all these fluorines, it seems like we're okay. 6 times 4 is 24. 2 times 4 would be 8. That's 32. So we're missing, so that's lone pairs on both sides. That gets us up to 36 valence. The one exception with XeF4 is these lone pairs just happen to cancel out. And that's why it's also nonpolar. Because these are in the square planar, which we will talk about in a future video. So thank you for watching this video, and I'll see you in the next one.